How on earth have your family got a steam train? Well, my dad liked them, so he bought one.
It was just such a feeling, you know, I can't believe that he's actually done this. And, you know, it's an amazing achievement.
It's great to see progress, really, because it has been a long time, and I'm sure Mum and Liz will have something to say as well, but it is really good now to see that there's like a concerted effort, and obviously Nick coming in, which we didn't have that kind of focus for a long time, and I can see the difference that's made.
The important thing is that it's getting done in the end, because that's all we want. Kaz's daughter has never seen it running. She's only seen it in the shed, and it'd be amazing for her to see it on the tracks.
It'd be great to see it out running again, and I think it'd be good for the railway as well, because it's kind of an efficient engine, because it can pull a lot of passengers, from what I understand.
Like Elizabeth said, I too would like my granddaughter to see it running. It was quite a momentous occasion when it ran, and you know, so Liz were little. It was just a tremendous sense of achievement. And, you know, I'm sure, you know, all the team would feel that once it is running.
I think it'd be quite emotional.
But yeah, it will be. It will definitely be a bit of my dad going again.
And just seeing the joy that people see it when it goes along the railway that it brings, that's what this job's about. It's not about nuts and bolts. It's about the human element of it all.
It's incredible to think that our dad had a part in that, and now we are having a tiny part in it. Seeing it going again and bringing joy to all these people.
Yeah.
The plan today is we're going to show the process of making stays. We've started making stays in-house, which is a major step for the NYMR. We used to make stays manually on our old machines in the machine shop, but we've invested in a CNC lathe, predominantly for Hartland, which that's Hartland's boiler, upside down at the minute.
Why is it upside down?
Ease of work. Some jobs require boilers to be upside down. If you're working on things like the foundation ring around the top, that's normally on the bottom. So you need to turn things upside down for ease of maintenance and just accessibility. And we do that with our really fun big steam crane. But we have many boilers on the NYMR. So we've got narrow box, wide box, we've got steel inner boxes, we've got copper inner boxes, we've got vertical boilers, but they're all one component in common, and that's stays. And when we're talking about stays, that's these. So these are rivets, and these are stays. And the stays hold the two plates together, so there's an outer plate and an inner plate, and then that's your water space. And the stays are a structural component holding them two parts together. So as you can see, this boiler alone has hundreds on this side, and Hartland has over 2,000. They're all different lengths. There can be different diameters, and if we can make them in-house, that's a huge cost the NYMR can save, because our volunteers can make their stays, and we're only buying the materials in at cost price, and we can turn the raw rods into stays. The shortest ones in Hartland are about 6 inches long, and the longest ones come up round this corner, these complex curves. So around these complex curves, some of these are up to 8 or 9 inches in length, so they're quite a thing. Well, we need stays because this is a pressure vessel. So our boilers, the maximum one we have, I think, is £250 per square inch boiler. So the boiler's always trying to expand itself. The metals are always trying to move out from the pressurised vessel it is. And now the middle bit is where the fire goes in. And again, this is upside down. But the water space is in here. So you've got one plate, which is the outer, one plate's the inner, and the pressure's trying to separate them. So the stays hold everything really rigid. And they're almost a structural bridging piece. They're different to a rivet, which locks materials together. This allows this part to have water, well, predominantly water or steam, depending where the water level is. It allows water in this passage so the fire can heat it up and then create the pressure. But without them stays, both plates would be ballooning, and then you get a structural failure, which is what we don't want. So back in the day, they'll have all been individually made by a craftsman on a machine, and it would have been the skill of the craftsman to get the tolerance. So each stair needs to be within a couple of thou in tolerance. So what that means is the hole's a certain diameter that's been measured, and we need the stair about 2/1000 of an inch smaller, so they can be wound in nice and tight, and then they're as steam tight as possible for when the tooling happens. So that would have been hundreds and hundreds of machinists making stairs for every boiler works throughout the land, and that would have been done on an old traditional lathe. Might have been done on a capstan lathe, where the tool setter could set the lathe up for a lesser skilled person. That happened a lot in the war, but generally it would have been machined by one machinist on his lathe making stairs, and it would have been production machining that's, well, you don't see nowadays because CNC's taken over. So as the chaps in our team are on fitting the stairs, this is the toolkit you need. So every hole gets drilled with a conventional drill like you'd use at home for steel. Its mate in the second plate gets drilled, and then to make them concentric with each other, we use these really long reamers. So that goes through the first plate into the second plate, and then the reamer makes them in line with each other, and then we make the threads, and these are the taps. We've had these specially made, so you can see how they're tapered up to a threaded part, and then this threaded part will be final finished size. Now from that small 1/4 of an inch hole to that size will be 20 or 30 passes with tools. It could be, if we get up to the really big ones, you're taking a slither off at a time, and then the reamer doesn't actually quite take all of the thread out, so the next tap picks up the thread. So they're really labour intensive of boilers. But then we fit these, and these are the stairs we've made in-house on our new CNC setup. So the thread is continuous, so the machine threads the whole thing. So as we wind it in, because that's left a continuous thread, this has to be continuously threaded, and then the machine takes out the undercutted portion there. And then there's predominantly 3 different materials, so steel, copper, and there's also stairs made out of a material called monel, which is hard. And the monel ones go around generally welded areas or high stress areas that the designers highlighted when they were first making the boilers. We're not going to make the monel because the monel needs a slightly different setup, and it's a hard machine it's a hard material to machine. But we could do copper. Well, we could do monel, but as we're just making baby steps, this is our first journey into making stairs. We're going to concentrate on the steel, because steel's not only cheap, it's a relatively good material to machine while we're getting good. And we have other machine shops around Britain that can make the monel for us. Hartland's a bit unique because it's a fully welded boiler. This is 825, S15, Essex Locomotive Societies, and this is a traditional boiler where it's made with plates, and all the plates are hand fitted, and then all in here will be tooled in, so we'll cork all the joints. There's very little welding on this boiler. Hartland is all welded on the firebox side, the inner and the outer. So, because they're all unique, one of our dedicated boiler team, Will Parish, has measured, you see all the different measurements, well that's the measurement from the outside of this plate to the inside of that plate to give us our length. So as you can see, he's drawn around all the ones that are in the same length. Now the shortest ones we have are 6 inches, but you can see this batch here is 6 1/4. We've got some 6 1/2 there, look. That won't be the only batch of 6 1/2. We'll have 6 1/2 further on, we'll have 6 1/2 on the side. So it's like the ultimate dot to dot. So to do the tapping and reaming operations, our team have air tools which are right angle drives, and they'll be stood here, and as they put power on, that's how the reamers get powered through all the threaded portions, the taps. But they actually fit the stairs by hand. So we've got stud blocks, and they'll be wound in with a spanner, and That stops any threads being ripped off if there's anything wrong, but it also allows the boiler smiths to have a bit of feel to know how tight they're going in. Because I say they have to be machined to a tolerance. You might have noticed some of our stays have coloured ends. That's to do with material certification. So everything on a boiler needs to either be coded welded, so it has to be done by a professional who's got industry standard welding codes, and the stays have to be of a known material. So we got a batch from our supplier in York of steel, and we sent that away for mechanical testing to make sure it was the right grades, because the modern grades are different to what the design grades were, just because of how things move on. But the modern grades are correlated to the old grades. And what we then do is everything with that batch that's got the mechanical and the chemical cert, we paint the ends. So the boiler inspector can then see where we've plotted and fit the stays on that boiler and which cert that correlates to. We have to send us samples of raw material to the laboratory, and they perform the pull test, the breaking tests on it, and they give us. They don't tell us if it's good enough. They tell us exactly what the material did, and then we talk with our inspector to get the okay to use it. So on the basis that the first batch was good, we bought the whole stock that our stockists had of that one material cert, just to make it all efficient. It's all the same size, so we're very confident we're going to use it all on this machine, this boiler, but we bought the whole lot just because we don't then have to go through getting the resets and the testing done again, just so the lads on the CNC can then just crack on. So these are the last bits of the initial batch we bought of the raw material, and because we know the material's correct and we've done the mechanical testing on it, we then bought what the stockist had left of the same batch. So we're not doubling up on testing. This rack's only for stay material, so we're not mixing it up with the general steels further down the shop. And then again, they just get it, cut it to length, put it in the machine, put threads on it. Yeah, it's all confidence. The whole thing's confidence. Like we mentioned before, it's 200 odd PSI in there. You need to know it's going to be right. And the insurance chap won't pass it otherwise. And when the insurance inspector comes, he'll need to see all the material certs. He'll want the chart of where all the stays went. He'll want the competence of the boiler smiths. Well, he knows that because he's worked with us a long time, but he'll want the full set of drawings. He'll want the coded welding certs. And it's just, we literally produce a dossier of evidence of what we've done. So even though we're making the CNCs in a modern way, it's still a very human feel. Tom there has fit 5, and it's still done with hand tools, and it's all about feel, so you don't rip a thread off. And then he has to set them all to the right length, because then all these need hammering down with the big air tools. So we have to set them all to the right depth. So the hammered over heads on the inside leave a nice head so they don't get eaten by the massive flames that are inside a boiler. Even with 𝙤𝙊𝘾𝙄𝘼 that we're converting to oil, it still needs stays. It's only the fuel source that's going to change, but the stays will still hold the inner and outer boxes together, which you can see further down with this one. And the stays are just hidden behind this cladding sheet, but they'll still be the same stays, the same equally spaced, you know, to hold the two plates together. But oil conversion needs stays, so there's a lot of future in this, and this is the setup we're using. On the back of the Hartland project, the CNC lathe was bought by the railway, because like I said, there's 2,500 stays to produce for that boiler alone. So they had a lot of foresight, and we've installed it in the boiler shop so that, you know, the minimum walking distance, that they can literally take a stay off this machine, fettle it, go and fit it. We've got money in the budget this year to put a shed around this to keep it nice and warm and clean. But like many things in railway preservation, it's stage one: get the machine in, get producing. Our volunteers like Kevin are making the stays, so the actual cost is as small as we can make it for the railway to make these stays. Some stays, when you buy them off suppliers, can be up to 40 quid each. Yeah, some of the complex ones. So as many as these we can knock out ourselves to tolerance, so our inspectors are happy. That's only a win. Stage 1 of any heritage engineering project is to get the machine up and running, but we're after a shed to go around it. So if anybody's got one, everything here is beg, stolen and borrow. We're not proud we'll have anything. So the CNC lathe, we were very fortunate to have Andrew join us, who's not here today, but he's a CNC operator. But another stage is we're looking at sending some of our fitters away to train them on CNC machines, and that'll be with a local training provider at Malton. That's up and running. And then the buy a stay scheme for the Green Knight, they're coming off this machine. So anybody wants to buy a stay, fund building a boiler, and you can't come through the door and help us, buy a stay, and you can see in action when it thunders past us going to Pickering or to Whitby to the seaside.